IntegraLink is TRC's project collaboration portal, connecting people, data, and systems. It is used daily by nearly 2,000 users, both in the office and in the field on mobile devices. It leverages the familiar, fast, and reliable Google mapping and search capabilities, making it accessible to all project stakeholders. This familiar look and feel means that your project teams can start visualizing and collaborating immediately with minimal to no training. For example, we can perform a simple text search identical to what you would do in Google Maps. So here we'll type in Nunn, Colorado, which is a town near our pipeline. You'll notice the green section at the top of the search panel, which is dedicated to Google Places results. These are one of the most frequent types of searches, as it allows folks to use commonplace locations to quickly navigate the system. From here, we can simply zoom to that location. Now that we've quickly navigated from a high-level view of the project to a more detailed view, let's talk about what we are seeing. Again, the base map is very familiar because it is the same as you would see if using Google Maps. The difference is the project data that is being overlaid on the base map. Here in this drop-down, we can see a list of the layers being used for this project. This list will change as the project evolves. These layers also reflect the many disciplines and organizations contributing to the success of the project. More specifically, I'm referring to the people component of IntegraLink's mission to connect people, data, and systems. For example, the landowner data, represented by our land and right-of-way team, the pipe type and workspace information coming from our engineers, the surveyed stream and wetland data coming from our environmental survey crews. All of these may be TRC's responsibility or the responsibility of many organizations. The point here is the information in IntegraLink is in lockstep with the project, but more importantly, IntegraLink represents the single version of the truth with respect to project deliverables, and where stakeholders who share the common goal of providing value to their customer have a common platform to visualize data in context to other deliverables and collaborate on the project with no concern that they are working from the most recent information. Getting back to what we're looking at, right now we are seeing landowner data symbolized based on survey permission. That same landowner data is also symbolized by title status. This gives all project stakeholders a quick, at-a-glance update of the project activity. We'll see more of these examples when we look at the pipe tally and weld mapping workflows. While we're on the topic of project data, recall how familiar and easy it was to search for that Google place, Nunn, Colorado. Taking it a step further and using that same familiar and easy approach, let's search our project data. In this example, I'm interested in seeing all HDDs on the pipeline. So I simply need to type in HDD, and this could just as easily be a heat number, landowner name, or track number. And I'm provided a list of all HDDs on my pipeline. From here, I can view the details of them individually. I can also get driving directions to this particular asset on the pipeline. I can zoom to each of these assets. And from here, I can also leverage the very familiar and reliable Google Maps imagery, giving us the location and situational awareness we've come to rely on with any online mapping system. We can also make use of Google Street View technology for those areas that cross or are parallel to the pipeline. And this just gives us a more detailed ground level awareness of our system. Another way we can get to the information about our project data is to simply click on or near the project asset. And we will quickly be provided with the results specific to the area where I clicked. And although this is very helpful while sitting behind the desk, we have hundreds of users today taking advantage of this feature on their mobile devices out in the field. IntegraLink is more than a visualization and project collaboration platform. It is also an integral part of TRC's construction solution, which includes support for pipe tally, material tracking, weld mapping, and as-built survey. Our solution emphasizes efficiency and data integrity. and all the while publishing the deliverables to IntegraLink in virtually real time, promoting constant monitoring. This video will highlight the pipe tally, material tracking, and weld mapping workflows. Traditionally, satisfying supply chain and surveys requirements for these tasks has required separate efforts and personnel, as well as point solutions that are often burdensome from a cost and implementation perspective. Furthermore, the deliverables are often in disparate silos, compromising data integrity, which can have a profound and long-lasting impact once the information is loaded into the enterprise database. We have designed a cost-conscious solution that leverages consumer-grade GPS, such as iOS and Android devices, virtually eliminating the need for expensive and difficult-to-implement GPS solutions. Also, and unique to the industry, our workflow eliminates the need to hire separate vendors to conduct pipe tracking and surveying. Whether we start at the mill attaching barcodes or on the right-of-way tallying pipe, rest assured you will have traceable, verifiable, and complete records at the end of the project and visibility throughout the process. Let's look at a pipeline construction project happening in northern Colorado. Here we can see the pipe tally and material tracking data symbolized based on location. The green squares represent pipe joints on the right-of-way, and yellow are joints in the pipe yard. As the joints are moved from the pipe yard to the right-of-way, our survey crews are scanning barcodes and updating the location, which is essentially accomplishing the task of pipe tracking and pipe tally at the same time by the same personnel. Our solution supports working in both a connected or disconnected environment. As this information is synced with IntegraLink, project stakeholders have consistent and reliable visibility into the material tracking progress. We can also view the same information in a tabular format. In this example, we are summarizing total length and count based on location. We can also get detailed data about these records too. Here you can see some of the attributes being captured. If available, we can preload this information directly from the mill's shipping manifest to help further ensure data integrity. We can also seamlessly associate barcode photos with the data, once again building a traceable, verifiable, and complete data set. Moving on to weld mapping, as shown by the black squares, we build on the information captured from the material tracking and pipe tally effort. This will ensure data continuity. For example, only joints of pipe and fittings that were tracked and tallied on the right-of-way will be available in the weld mapping task. As welds are completed, our survey crews will photograph the weld and populate the up and downstream joints. At this point, a project stakeholder could verify the correct joints are associated with a given X-ray. For example, here we see joint numbers ending in 619 and 610, which is consistent with the attributes in the weld mapping database. We could also validate the X-ray number too. We could also take this a step further and validate that the attributes in the material tracking and pipe tally database are consistent with what's on the mill's barcode information.
Following weld mapping, we move into the as-built workflow. From this vantage point, project stakeholders have a bird's-eye view of as-built survey progress, similar to what we were seeing with material tracking and weld mapping. In this case, you are seeing green X's, which represent the welds. With keeping the end in mind, we will leverage the data collected during the weld mapping effort to help ensure data integrity and minimize data errors. For example, here, you can see the up and downstream joints and the X-ray number in the as-built data is identical to that which was collected in the weld mapping effort. Our survey teams will perform as-built survey and on a nightly basis upload the information into TRC's mapping data solution, also known as MDS. This is another example where our solution and technology differ from others in the industry. Through an automated and manual validation process, the MDS system and our survey techs will audit the spatial and attribute correctness of the data, as well as conduct context validation, which means verifying whether or not the appropriate material was installed in the appropriate location, and verifying the pipeline is not being constructed outside of the predefined easement. This system will also facilitate associating the necessary documentation, for example, the MTRs or X-ray inspections. For those records that don't pass validation, they will be immediately flagged for further review and resolution. It is important to mention that this is happening on a daily basis, allowing our data and survey teams to identify and resolve issues while we still have boots on the ground, and in many cases while the trench is still open. Finally, and similar to weld mapping, pipe tally, and material tracking, the as-built data is visible in IntegraLink on a daily basis. So anyone on the project team, including inspection, can visually track the progress as well as spot check the quality of the data being collected. For example, we can verify the weld spatial location, or in this example, we can validate that the heat number associated with the record is actually in the MTR documentation. If an issue is found, we know that we can walk backwards through the weld mapping and material tracking data to identify where the issue arose. The as-built data is managed in a GIS, which allows for simple delivery into industry data models. So not only is TRC's construction process providing a cost-conscious solution and also constant visibility into these efforts, but we are stitching together a traceable, verifiable, and complete representation of the pipeline as it would be loaded into the enterprise pipeline database.